I'm going to start by talking about the future of being human by going back to a quotation from 1670 from Blaise Pascal, who pointed out that man is equally incapable of seeing what's happening at the infinitely small levels from which he emerges as he is incapable of seeing what's happening at the infinity in which he is engulfed. In other words, we're all trapped on this infinitely small strip between atoms and galaxies, and we don't really see most of what's happening in our reality. So that was 350 years ago, and the march of science has only made that worse. In the following sense, what we've realized is that we don't see most of what's happening at our own spatial scales. So let me give you an example of this. Take electromagnetic radiation that we call light, visible light. This bounces off of things and strikes photoreceptors in the back of our eyes, sends electrical signals to our brain, and we see. And so our whole world is, we're surrounded by this electromagnetic radiation that we love. But it turns out there's lots of electromagnetic radiation. We could call it all light, but the thing is that this little strip that we think of as the part we can see is 1/10 trillionth of what's going on out there. So right now, passing through your body is NPR and CNN and gamma rays and X-rays and microwaves, all kinds of things that are completely invisible to you, even though it's the same stuff. Now, why is it invisible to you? Because you don't have specialized biological receptors for picking up on it. So as far as you're concerned, it doesn't even exist. Now, it turns out that not all animals are limited to the same range we are. So, for example, snakes see in the infrared range, so they can see a little bit farther out than we can. And honeybees see in the ultraviolet range, and bees and flowers communicate with each other this way in this range that we can't see. And of course, we build machines in the dashboards of our cars to pick up on radio waves, and we build machines in hospitals to pick up on X-rays and things like that. But we can't see any of that stuff. And so what we're able to experience, what your human experience is delimited by, are the biological receptors that you happen to come to the table with. Isn't that stunning? So it turns out that every animal, as you look across the animal kingdom, has their own window on reality. And the reason is they have different biological receptors. So for the blind world of the tick, the signals that it gets from its ecosystem are heat and the odor of butyric acid. Those are the signals that it's picking up on to figure out what its world is. And for the black ghost knifefish, what it's picking up on is electrical fields. That's what it's getting from its ecosystem. And for the blind echolocating bat, it's air compression waves. And the key is that these are all the signals that it gets. And we have a word for this in science. This little window of your reality based on what you can pick up on is called the Umwelt, which is a German word that means the surrounding world. And the really stunning part is that somehow all of us, presumably animals and so on, imagine that our Umwelt is the entire objective reality out there. So for example, in the Truman Show, Truman lives in this world that's constructed, usually on the fly, by this intrepid producer. And in the movie, there's a part where an interviewer asks the producer, why do you think it is that Truman has never come close to discovering the true nature of his world? And the producer says, we all accept the reality of the world as it's presented to us. It's one of those rare Hollywood lines that nailed it, right? So here's the thing. I want to do a consciousness raiser on that so we can really get what this is like. So I want you to think about what it would be like to be blind. So let's say you're born blind. What's that like? Do you think it's sort of like a blackness or a hole where vision is supposed to be? So if that's your intuition, it turns out that's wrong. And the reason it's wrong, to understand that, let's take an example, a thought experiment, which is imagine that you are a bloodhound dog. Your entire world is about scent. It's about olfaction, smell. You've got this really long snout with 200 million olfactory receptors housed in there. You've got wet nostrils that attract and trap scent molecules. You have flares slits in your nostril that allow the nostrils to flare when you breathe in, so you bring in more odor. You even have these long floppy ears so that you, as you're walking along, you're kicking up scent molecules and smelling them. Your whole world is about smelling. Now let's say one day you're following your master, your human master, and you stop in your tracks with a revelation. And you think, my God, what is it like to have the pitiful little nose of a human? What is it like to take a feeble little nose full of human air? Like, you don't smell anything. That must be like a hole where smell is supposed to be, or a blackness that they're missing. But of course, since we all have the experience of being human, we know that we don't miss it. Why? Because we never experienced it. It's not part of our Umwelt, and therefore, we didn't even think of it as something that we are missing, that could have been a part of our Umwelt. And so it goes with the congenitally blind. They don't have darkness or a hole there. They're not missing it because they never had it. So here's another example. For people who are colorblind, you can't even imagine that other people are seeing hues until you're told that this is true and that other people are having an experience that you can't. And if you've got normal color vision and you feel pretty good about that, just keep in mind that we now know that some fraction of the female population has not just 3 types of color photoreceptors at the back of their eye and their retina, but they have 4 types, which means that they're experiencing colors that the rest of us can't see. So for those of you who are not members of this small population of tetrachromatic females, you've just discovered that you've got an impoverishment that you didn't even know about and you didn't even miss. So, now to the context of this talk. What I'm really interested in is, as we move forward, how are our technologies going to expand our Umwelt and therefore the experience of being human? So I promised myself as a rule for this talk that I'm not going to extrapolate into the future. What I'm going to do is take innovations that are present right now, things that are happening right now, and ask it in this context about how are we using our technologies to expand our experience of being a human being. So many of you probably know that there are hundreds of thousands of people walking around right now with artificial retinas and artificial inner ears. And this has been a tremendously successful technology. Essentially, you take a camera and you digitize the signal and you stick it on a chip at the back of the retina, which then talks to the optic nerve, or you take a microphone and you digitize the signal and you put in a multi-electrode into the inner ear and you communicate to the auditory nerve. And what these have proven is that we can marry our technology to our biology. But here's the really critical part. As recently as 20 years ago, many or most scientists figured that this wouldn't work. Now, why would they think that? Well, it's because the way that we build these technologies, these chips and electrode arrays actually speak a slightly different language than our natural sensory organs. And so the question is, how is the brain going to figure out this other language that's not quite right and doesn't do all the pre-processing that the retina does or the inner ear does? But you know what? It turned out not to matter. The brain figured out how to understand it, and people can see and hear with this. Now, what's the secret here? Well, the thing to understand is that your eyes and your ears aren't doing the seeing in the first place. Your brain's doing the seeing, and the thing to appreciate is that it is locked in silence and darkness in the vault of your skull. So all the brain ever sees are electrical signals coursing around in giant populations of neurons. That's all the brain ever experiences. It's not seeing the light or the dark out there or the colors. It's not hearing the conversation. This is all that the brain is experiencing and nothing more. But the brain is so tremendously flexible that what it's really good at doing is saying, okay, well, I've got these data cables coming in. I don't know what information is carried on. I mean, we call those data cables the optic nerve and the auditory nerve, but it doesn't know what it is. All it sees is this kind of stuff, but it's really good at extracting patterns and figuring out what to do with them and eventually, amazingly, how to have a direct perceptual experience that it constructs about the outside world. This, by the way, is the great unsolved question of neuroscience, is how you ever convert this sort of thing into private, subjective experience. But in any case, the brain is so good at doing this and so flexible that in my next book, I suggest that this is Mother Nature's great secret, is building this sort of system once, and then you can drop it into any body plan, and it'll figure out what to do. And what I call this is the Mph Model of Evolution. And I don't want to get too technical here, but by MPH, what I mean is Mr. Potato Head. And the reason I call it this is because it turns out that the brain doesn't care what the peripheral devices are that you plug in. These organs that we know and love, like eyes and ears and fingertips and nose, these are plug-and-play peripheral devices. And you can put in anything you want into the system, and the brain will figure out how to use it. This is really stunning, but true. And the reason we know this is because when you look across the animal kingdom, you find lots of different peripheral devices. So, for example, snakes have heat pits, those black areas underneath the eyes. Those are heat pits. That's how it detects the infrared. The black ghost knifefish that I showed you has electrosensory organs all up and down its body, things that we don't have. That's what allows it to detect its Umwelt. This is an animal called the star-nosed mole. This thing in front of it is its nose, which is essentially made up of 20 fingers. And this mole burrows through dark tunnels and feels the world with its 20-fingered nose. That's a weird peripheral device to plug in, but it works just fine. So it turns out cows, as well as birds and insects, they have magnetite, which allows them to orient to the Earth's magnetic field. So because they have that, they're able to operate on it, whereas we don't, and so we're unaware of where the magnetic field is oriented. So what this means is the particular plug-and-play devices that you come to the table with, this is what shapes your reality. This is what allows you to experience your little section of the world here. And so the lesson that surfaces here is that there's nothing really special about these particular organs that we have. These are just what we've inherited from a long, complex evolutionary history. This is what we happen to come to the table with. But it's not necessarily what we have to stick with. And there's flexibility in the system. And this is what leads to the idea, and really I think the proof of principle for the Mr. Potato Head model, of sensory substitution. Which is, could you actually feed sensory information into unusual sensory channels, and would the brain figure it out? So this might sound crazy and speculative, but I want to point out that the first demonstration of this was published in Nature in 1969. So a scientist named Paul Bakke-Rita took a camera, and he fed the video feed into grids of solenoids on the back of a dental chair. So you sit in the chair, and whatever passes in front of the camera gets poked into your back. And so if you put a face in front of the camera, then you feel that pattern in your back. And he sat blind people in the chair and had them experiment with this for a while. And it turned out that they got pretty good at being able to see or being able to report what they were seeing with their back. Okay, well, this has had a lot of incarnations since the late 60s. So here, for example, this is a version of it's called sonic glasses, where you convert the video stream into an auditory stream. So as things get closer and farther, it goes like that. And it sounds crazy at first when you put it on. It doesn't make any sense. After a while, you're able to walk around and not bump into things and so on. But after a few weeks, people actually have direct perceptual experience, essentially seeing. Here's another incarnation. This is the forehead version of it, where there's a small grid of tactors on your forehead, and it turns a video stream into feeling on your forehead. This is the most modern incarnation. It's called the brain port. It's an electrode grid that sits on your tongue. Why your tongue? Because it's got high resolution, got a lot of sensory receptors there, and you take the video feed and you convert it into what's happening on the tongue, and people come to see with the brain port. I mean, they actually report that it is vision. Now, I know that sounds crazy, but remember that all vision ever is electrical signals coming into your brain, and it doesn't matter the route by which they get there. Okay, so people can actually rock climb wearing the brain port, or they can toss a ball into a bucket. So it's a pretty amazing demonstration. And I think what sensory substitution shows us is this principle that the Mr. Potato Head theory is right, in that you can plug in anything you want here. Now, one of the projects my lab is doing along these lines is we want to use sensory substitution to solve the problem of deafness. And so I want to tell you about that project, and for that I'd like to introduce my graduate student, Scott Novich, who's spearheading this work for his thesis.
Hey everyone. So the application that you see David running behind me is a demonstration of how we envision sound-to-touch sensory substitution to work. So what happens is sound comes into the system in real time.
The quick brown fox.
It gets compressed and then mapped to some sort of wearable device, such as a vest. And this vest has an array of tactors on it, which could be little vibrational motors. And those vibrational motors here are represented by these black boxes, which light up according to how much they're being stimulated.
Jumped over the lazy brown dog. Was that I don't jumped over the dog? Yeah, fine. Yes.
Right.
I don't even know the expression.
So we started working on the system a while back. We were building all sorts of complex electronics to make it happen. And then we had this epiphany. It's not 2008 anymore. We actually have all this technology right here in our pocket. So what I have here is an actual copy of the same application that's running. And not only that, yeah.
In the second half of the talk, I do the full Monty, so just wait for it. Yeah.
Right. So we have the fully working prototype, and it actually goes into my Android phone, and I can turn it on. And what happens is I can talk into it, and can you hear it?
Can you guys hear the buzzing?
Maybe. And in real time, it gets mapped to the vest wirelessly over Bluetooth to David. So
great.
That's our vest.
That's the vibratory vest. And the idea is this. Our expectation, in the coming months, we're going to be testing this with deaf participants. And our expectation is that in the course of about 2 weeks, they should be able to develop a direct perceptual experience of the sound in their environment. In the same way that when you watch a blind person reading Braille, they're having a series of patterns going over their fingers, and they have a direct perceptual experience of that, the same way that we read font and think it's immediately right there. So the idea is, if this works well with deaf people, this will really be a game changer, because we can build this for 100 times cheaper than you can do a cochlear implant, and this doesn't require an invasive surgery. So we have high hopes for where this is going. But in the context of this talk, I don't want to just talk about sensory substitution. What Scott and I are interested in is sensory addition. How can we use this kind of technology to actually expand the human Umwelt? So there are lots of ideas here. So just as one example, imagine if I wanted to have perception of something larger than normally a single human can have. So instead of just sensing what's immediately here, imagine that we feed in real-time data from the net about weather patterns of the surrounding 200 miles. And by tracking those patterns and feeling them all day while I'm walking around unconsciously, because the brain's really good at extracting patterns without having to pay detailed attention to it, if I could feel the surrounding 200 miles and be able to predict the weather better than the weatherman can, and tell you guys what's happening next, that's opening up my Umwelt into something that humans haven't had an experience with before. And a related idea, one that we've actually started moving on, is what happens if I walk around all day and I feed data from the stock market into me while I'm walking around all day? And again, I don't have to pay any attention to it. But what I'm doing is I'm tapping into the ebbs and flows of the economy of the world, right? And that's an experience that humans simply haven't had before. It just hasn't been part of our Umwelt. And so the idea is it gives us a totally new experience to deal with here, and we're working on this right now. Here's a third idea that we're working on. So you guys have all heard of the Spidey Sense. So what we want to build is the Tweety Sense. So imagine that every single tweet that's been going out of this room all day that has the hashtag BeingHuman2013, imagine that we've been tracking every one of those, which we have. And imagine that as I walk around in the vest all day, I am plugged into the consciousness of 1,000 people. Because what I'm getting is the sentiment of 1,000 people who are all experiencing something, but I'm feeling that sentiment as I'm walking around and doing other things. And I know when things are ebbing and flowing there. So, and if we really wanted to blow up on this, one of the things that we've been thinking about a lot is that, Twitter really has become the consciousness of the planet, in the sense that the ideas that people really care about most, those trend up above the noise floor and rise to the top. So imagine now that you want it to be plugged in not just to 1,000 people, but you wanted to expand your Umwelt to the entire planet. And you wanted to know what's going on at any time. So you compress 500,000 tweets per second through some natural language processing, and all day you walk around and you're feeling what's going on. And you'd be, oh, something bad just happened in Kenya. And you would know that before anybody else. That's the idea of the Tweety Sense, and the idea is that you would become very worldly in a sensory sense. Now, who wants to be plugged into the consciousness of the world? Who knows? But that's one of the things we're experimenting with. Thank you very much, Scott. Okay, so that's the idea with sensory substitution. And And it turns out ours is just one of many projects happening all over the planet with this sort of thing. So one popular thing that many biohackers are doing is implanting neodymium magnets into their fingertips, and then suddenly you become aware of the electromagnetism around you. So there are, I think, at least 1,000 people who've done this so far. And the idea is then, let's say there's a power transformer, you can feel the shape of the electromagnetic bubble around that. And you feel the shape and the size and the strength of it, and some people even describe you feel the color of it because of the frequency of the electromagnetism. And people can do things like, repair their electronics just by feeling where there's power running through the cables without having to break out their multimeter. And that's one way of expanding the human Umwelt. This in the lower left is Neil Harbison, who is born colorblind, and so he set up what he calls the iBorg, which is a color camera that converts different wavelengths, colors, into particular sounds that he experiences through bone conduction. And so now he goes around the world and really enjoys and experiences color. This is his girlfriend, Moon Rebus, who puts what she calls the Speedborg into her earlobes so she can do motion detection of everything around her, and she can stand in a crowd and really feel what's happening with the crowd. And really, there is no limit that we can think of to the number of sensory expansions that we can do, like 360-degree vision or infrared or ultraviolet. Wouldn't you like to experience that? Or not just expansions, but additions, things that are absolutely new things that humans have never experienced before. And so the bottom line is the human Umwelt is on the move. We are now in a position, as we move into the future, of getting to choose our own plug-and-play devices. And we're no longer a natural species in the sense that we don't have to wait for Mother Nature's sensory gifts on her time scales. But, nature, just like any good parent, has given us the tools that we need to go out and construct our own experiences.